Hello students, welcome back to Husky Math. Today we will start integration by parts. So integration by parts is a method used to integrate the product of two functions. So if there is a function of x into function of x, and if I have to integrate the product of these two functions with respect to x, then there's a rule where we have to integrate in this way, keeping fx first and integration of gx minus integrating ddx of fx into integration of gx, dx and dx. So this is the rule which we will be using to evaluate the product of two functions and to integrate them. So rather than this, I want you to remember like this: if there are function of x and if there is a product of these two functions, the function first and the second function, so integration by parts says that keep first function first and integrate the second minus integration of, use a curly bracket, and differentiate the first function into integrating the second function, curly bracket close, and dx. So this is integration by parts. Question 1. Evaluate x into log of 2x with respect to x. So here there are two functions getting multiplied. Those are x and log of 2x. So here we will be using integration by parts. But the question arises is that in these two functions, which one is the first function? It's not like if x is first, then we will consider x as first function. It's not like that. So here x is an algebraic function and this is an logarithmic function. So for that we have one more rule which we have to remember, that is I lit, and add c also at last. So here I means inverse trigonometric functions, L means logarithmic function, A means algebraic functions, T stands for trigonometric functions, E for exponential, and C for constant. So seeing this I let C rule, we will be considering the first and second function. As you can see in this question number 1, there is algebraic function and log function. So from here the logarithmic function should be considered at first and algebraic function should be considered at second. So here this is my first function and this is my second function. So using integration of parts, which I have written here, integration of x into log of 2x equals to the first function, that is log of 2x, we will keep log 2x, and integrate the second function, that is x, minus integration of curly bracket open, differentiating the first function, that is log of 2x, into integrating the second function, so this equals to log of 2x into integration of x is x square over 2 minus integration of derivative of log of 2x is 1 by 2x, and due to chain rule ddx of 2x is 2, into integration of x is again x square by 2 here, curly bracket close, and dx. So here there are 2 dx, that means this dx is for this particular integration and this outer dx is for this particular integration, equals to x square by 2 log of 2x minus here 2 and 2 got cancelled, integration of here x and this square is also getting cancelled, so we will have x by 2 dx, and this equals to x square by 2 log of 2x minus 1 by 2 is constant, and integration of x is x square by 2 plus constant of integration at last, and this equals to x square by 2 log of 2x minus 1 by 4 x square plus c. Question 2. integrate x square into e to the power x dx. So there's an algebraic function and exponential function, and looking at I-let C rule, I have to consider algebraic function as first function and exponential function to be second. So here this is my first function and this is my second function. So using integration by parts, we will keep first x square and integrate second minus integration of d dx of first function into integration of second function dx equals to x square integration of e to the power x is e to the power x minus integration of d dx of x square is 2x into integration of e to the power x is e to the power x curly bracket close dx. This equals to x square into e to the power x minus 2 is constant integration of x into e to the power x dx. Now we will be using product rule again here, because again there are two functions getting multiplied, that is x and e to the power x. So here we will consider this again as first function and this to be second using I-let C rule. This equals to x square e to the power x minus 2 is constant. Let me put a square bracket. Now let us evaluate using integration by parts, keeping first function, integrating second, minus integration of d dx of first into integration of second, it equals to x square e to the power x minus 2 x integration of e to the power x is e to the power x minus integration of d dx of x is 1 and integration of e to the power x is e to the power x only dx equals to x square e to the power x minus 2 into x into e to the power x minus e to the power x plus c. This equals to x square e to the power x minus 2x e to the power x plus 2 e to the power x plus c. So let us take out e to the power x common, then we will have x square minus 2x plus 2 plus c. Question 3. Evaluate sin x into log of cos x. So here also there are two functions getting multiplied, that is sin x and log of cos of x. So seeing I-let C rule, this is my trigonometric function and this is my logarithmic function. So I'll be considering log first and trigonometric second. So here this is my first and this particular is second. So evaluating using integration by parts, keeping first function and integrating the second minus integration of d dx of first function into integrating second function. This equals to log of cos of x into integration of sin x is minus cos x minus integration of d dx of log cos x is 1 by cos x, and due to chain rule d dx of cos x is minus sin x into integration of sin x is minus cos x and dx. So here cos x and cos x got cancelled. So it equals to minus cos x log of cos of x minus integration of, see here minus and minus will get plus. So here we will simply have sine x only with dx equals to minus cos x log of cos x minus integration of sine x is minus cos x, and that minus and minus got plus cos x plus c. Question 4. Evaluate log of 2 plus x square dx. So here you can only see one function, and that is log. Obviously there is an algebraic function, but that is inside log. So here overall there is only one function. So since there is no other function, we will consider this integral as log of 2 plus x square into 1 dx. So since previously there was only one function, now I have added one more function by multiplying it with the given function and made the product of two functions. So here this is my first function because this is a log function, and this I will consider a second function because this is a constant, and as you can see the constant lies at last in this I-let's-see rule. So now again evaluating this using integration by parts, we will have first function and integrating the second function minus integration of ddx of first function into integrating of 1 dx. This equals to log of 2 plus x square into integration of dx is x minus integration of ddx of log of 2 plus x square is 1 by 2 plus x square at first, and by chain rule derivative of 2 plus x square is 2x into integration of dx is x and the outside dx equals to x into log of 2 plus x square minus, here this 2 is constant, so let me take it out. So integration of x into x is x square by, let us write 2 plus x square as x square plus 2 dx. Now in order to evaluate this integral, let us divide x square with x square plus 2 first. So dividing x square with x square plus 2, then we will have x square 1 is x square and 1 into 2 is 2. Changing the sign, we will have minus 2 as remainder. That means this particular integral is integration of x square by x square plus 2 dx, and since I have divided the function, so here this I can write as 1 minus 2 over x square plus 2, 1 minus 2 over x square plus 2 into dx equals to, distributing the integral, then we will have integration of 1 dx minus 2 is constant and integration of dx over x square plus 2. So this equals to integration of dx is x minus 2. Now again to integrate this particular integral, there's one formula in the coming chapters, which is integration of dx over x square plus a square equals to 1 over a tan inverse of x by a plus c. So now I will be using this formula here. So let us modify this particular integral to integration of dx over x square plus this 2 can be written as square root of 2 whole square. Now this matches the formula here, then this I can write as 1 by a, that is 1 over root 2 tan inverse of x by a, that is x over root 2 plus c. So here rationalizing the 2 over root 2, we will have root 2 tan inverse of x over root 2 plus c. So let us put back the value in our main question. Then we will have equals to x log of 2 plus x square minus 2 into, the answer here is x minus root 2 tan inverse of x over root 2 plus c. So this constant of integration, you just write it at last. So my final answer will be x log of 2 plus x square minus 2x plus 2 root 2 tan inverse of x over root 2 plus c. Question 5. Evaluate integration of x sin inverse of x over square root of 1 minus x square dx. Before doing integration by parts, here let us do the method of substitution. Since I can see that derivative of sin inverse of x is 1 over square root of 1 minus x square. So here let us put sin inverse of x equals to t, and if I differentiate both sides with respect to x, ddx of sin inverse of x is 1 over square root of 1 minus x square dx equals to dt, and from here we can write x equals to sine of t. Therefore my integration I will be equal to integration of, instead of this particular x we can write sine t, so here we will write sine t, and instead of sine inverse x, that is we have considered t, and dx over square root of 1 minus x square is dt from this equation, so here we will have dt. Now since we have just finished the method of substitution, now we will integrate this using integration by parts, because there is the product of two functions, that is sine of t and t. And since algebraic function comes first and trigonometric at second from this ILHC rule, so we will consider this t to be first function and this sine to be second function. And using the integration by parts, we can write this as keeping first integrating second minus integration of the derivative of first into integration of second dt. So this equals to t into integration of sine t is minus cos t minus integration of ddt of t is 1 and integration of sine t is minus cos t dt equals to minus t cos t plus integration of cos t dt equals to minus t cos t plus integration of cos t is sine t plus c. Now let us put back the value of t. Sine inverse of x was t, so from here x equals to sine of t. Now here we can see that if sine t equals to x, then we can write the value of cos t to be square root of 1 minus sine square of t, which is from the identity, and hence the cos t can be written as 1 minus x square because sine t is x. So putting back the value in the given integral, we have minus, instead of t we can write sine inverse of x, and instead of cos t we can write square root of 1 minus x square, plus instead of sine t, from this equation we can write x plus c. So this is the answer. Question 6. Evaluate sine inverse of square root of x. So before using integration by parts, let us consider this sine inverse of root x equals to t. So from here we can get square root of x equals to sine t, and on squaring both sides we will have x equals to sine square of t. Now let us differentiate both sides with respect to x, then we will have ddx of x is 1 and ddx of sine square t is 2 sine t. Using chain rule, dt of sine t is cos t and dt. So this implies dx equals to 2 sine cos means sine 2t dt. Hence my given integral I will be equal to integration of the whole thing is t and the value of dx is sine 2t into dt. Now there is a product of two functions, that is t and sine 2t. And since algebraic functions come first before trigonometric function, so I will consider this to be first and sine to be second function, and evaluating using integration by parts, we will have first function integration of second function minus integration of the derivative of first into integration of second dt. So this equals to t into integration of sine 2t is minus cos 2t over 2 minus integration of ddt of t is 1 and integration of sine 2t is minus cos 2t by 2 dt equals to minus 1 by 2 t cos 2t plus 1 by 2 is constant, integration of cos 2t dt. This equals to plus 1 by 2, integration of cos 2t is sine 2 times t by 2 plus c. Now the integration has been done. Now let us put back the value of t plus 1 by 4 sine of 2t plus c. Now before substituting the value of t, let me make small changes here. We can write cos 2t as 1 minus 2 sine square t plus 1 by 4 sine 2t can be written as 2 sine t into cos t plus c. Here 2 1 the 2, 2 times 2 is 4. So this equals to, opening the bracket, we will have minus 1 by 2 t plus 2 by 2 t sine square t plus 1 by 2 sine t and cos t plus c. Here 2 and 2 got cancelled. Now let us put back the value of t. So we had considered sine inverse of root x to be t, from which we got x to be sine square of t. So here we will have minus 1 by 2, the value of t is sine inverse of root x plus t is there, that means sine inverse of root x, and instead of this particular sine square t we can write x. So here it will be into x plus 1 by 2. This sine t can be written as square root of x from this equation. So it will be square root of x, and in place of this cos t we can replace the value as cos t is equal to square root of 1 minus sine square of t. So, this equals to square root of 1 minus x. So, here we can write square root of 1 minus of x plus c. Question 7. Evaluate sine inverse of x divided by x square dx. So, we will consider I equals to integration of sine inverse of x into 1 over x square dx. So, here we see this as the product of two functions where sine inverse x is my first function because inverse is the first in the preference, and 1 by x square is an algebraic function which we will consider as second function. So, here this is my first function and this is my second function. So, by integrating using parts, we will have first function into integration of second function minus integration of d dx of first function into integration of second function dx. So, it equals to sine inverse of x, integration of 1 over x square is minus 1 by x minus integration of d dx of sine inverse of x is 1 over square root of 1 minus x square into integration of 1 by x square is minus 1 over x dx. So, this equals to minus 1 by x sine inverse of x minus, and minus is plus. So, integration of 1 by x into square root of 1 minus x square dx. Now, since the first term has been integrated, now let us look this second integral. Now, in order to integrate this second integral, let us assume x to be sine of t. So, let us put this x as sine of t. Then we will have d dx of x is 1. So, 1 into dx equals to d dx of sine t is cos of t into dt. Therefore, the second integral will be 1 by the value of x is sine t and square root of 1 minus of sine square t, and the value of dx will be cos t into dt from this equation. So, it is cos t into dt. So, simplifying the second integral, we will have 1 by sine t into square root of 1 minus sine square t is cos of t into cos of t dt. So, here cos t and cos t got cancelled, hence we will have integration of 1 over sine t, that is integration of cosec t dt. And we know the integral of cosec t is log of cosec t minus cot of t plus c. Now, putting back the value of t, since we have sine t as x, that means cosec t is the inverse of sine, so we will have cosec t as 1 over x. And since sine t is x, then we will have cos t equals to square root of 1 minus of sine square t, that is x square. Therefore, the value of cot t equals to cos of t divided by sine of t, and hence cos is square root of 1 minus x square over sine t is x. So, let us put back the value of cosec t, that is 1 by x, and cot t, that is square root of 1 minus x square by x. Hence, the second part of the integral will be equals to log of 1 by x minus square root of 1 minus x square by x plus c. Hence, my final integral, that is from this equation, is equals to minus 1 by x sine inverse of x plus the second part of the integral we got as log of 1 by x minus square root of 1 minus x square by x plus c. Question 8. Evaluate sine of log of x dx. So let I equals to integration of sine of log of x dx. So let us assume this log x to be t at first. So put log of x equals to t so that x will be equal to e to the power t. And let us differentiate both sides with respect to x, then we will have dx equals to e to the power t dt. So my integral becomes I equals to integration of sine of t, and the value of dx is e to the power t dt. E to the power t dt. Now here there are the product of two functions, that is sine of t into e to the power t, and looking at I let C rule, we will consider trigonometric function as first and the exponential function as second, and let us evaluate this using integration by parts. Then we will have I equals to first into integration of second minus integration of ddx of first into integration of second dt equals to sine t integration of e to the power t is e to the power t minus integration of ddx of, sorry, this is actually ddt, ddt of sine t is cos t into integration of e to the power t is e to the power t dt. Now again integrating this portion by parts, then we will have first function, that is cos, integrating second minus integration of ddt of first into integration of second dt. So this is my I. So my integral I equals to sine t e to the power t minus cos t, integral of e to the power t is e to the power t minus, now ddt of cos t is minus sine t, so that minus and this minus got plus, integration of sine t into integral of e to the power t is e to the power t dt. Now here we have to notice that this portion is the same as I. So instead of that, I can write I from this particular equation. So this implies I equals to sine t e to the power t, let us open the bracket, then it will be minus cos t e to the power t, opening the bracket, it will be minus. Now this integral of sine t e to the power t dt is my I only. So from here I plus I equals to sine t e to the power t minus cos t e to the power t, and hence I plus I is 2 times I equals to sine t e to the power t minus cos t e to the power t. So putting back the value of t, we will have 2I equals to sine of t was log of x and e to the power t was x minus cos of t was log of x and e to the power t was x. So I equals to, let us take out x common, then we will have sine of log of x minus cos of log of x whole divided by 2 plus c. See, always write the constant of integration. So this much in this video. We will be doing more of integration by parts in the next video. Till then, you practice more and more of this integration by parts.